Hello, today's lesson is about dividing mixed numbers. You'll notice the essential question says, how can you model division by a mixed number? Now, some people get confused by the word modeling. It means a couple of different things. A lot of times, a teacher, when they talk about a model, right, they're asking you to draw a picture a lot of times. Now, there's a math standard that asks you to model a problem. When you model a problem with math, that means you're solving a problem using math. And so those are the two different meanings of model. And then there's a big star because you know that I want you to write down something in your math notebook and I'm going to show you what it is. I've basically taken the steps from the textbook and made it easier. Now the key idea you'll see in the Big Ideas textbook, but here's the 4 steps that you're going to be doing. And then you're going to write this down in your math notebook, but you're going to remember that, I'm asking you to remember when you want to divide, look on the right side, flip that fraction over, and then you multiply. So in order to flip a fraction, you must change mixed numbers to improper fractions. Then you take the reciprocal of the divisor. Please never change the dividend. Then you multiply across, and then you simplify if needed. There is lots of simplifying to do today because a mixed number is already a number bigger than 1. So your quotients start getting larger. Please write that down in your math notebook, and let's go to an example. Write down this example in your graphing notebook. So the idea is if you divide a mixed number by a fraction, it's really not much different than what you did before. But I'm going to show you a picture. And so if I'm taking 2 1/4 and dividing by 3/8, here's kind of how we started to ask it, right? How many 3/8 fit into 2 1/4? Now I'm going to be strategic. When I draw a picture of 2 1/4, well, 2 1/4 what? I don't know, but 2 is my unit. And so it could be feet, it could be inches. Maybe I'm drawing a picture of like how big I want a poster to be, right? And then I'm trying to put together a little 3/8 of it. So because I know I'm going to be counting by 8, I'm going to make my whole made up of 8 little squares. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go ahead and make this be 1. 1, 2, 3, 4, 5, 6, 7, 8. And this is 2. Now, if it takes 8 squares to make one whole inch or foot or whatever I'm measuring, then a fourth of that, well, half of that would be 4 squares, and a half of that would be 2 squares. So this is where my 2 1/4 would be. And then, and you could do this with, circles or rectangles like I've showed you in other lessons. Okay, so I made my rectangle, and there are 2 1/4 of inches or feet, and I'm trying to count the number of 3/8 inside. So what I can do right now is I can just start here and count 3 at a time, right? 1, 2, 3. There's my 8. There's 1. 1, 2, 3. Now I'm up to 2. 1, 2, 3. Now I'm up to 3. 1, 2, 3, 4. 1, 2, 3, 5. And luckily this went in evenly, so you can see that there are 6 groups of 3/8, or 6 3/8 fit inside of 2 1/4. But then you also know that I've got this little rhyme. When you want to divide, look on the right side, flip that fraction over, and then you multiply. So now my answer looks like there are 6 3/8 that fit inside. Now let's just do it mathematically. It's called an algorithm. An algorithm are a bunch of steps that you do in math. And so I'm going to first turn this mixed number into an improper fraction. 4 times 2 is 8, plus 1 is 9. So I've got 9/4 divided by 3/8. Now I don't want to flip it first. I really do want to turn all the mixed numbers into improper. Because if I try to do improper, if I convert to improper and then I flip it at the same time, I start making mistakes. So now I'm going to rewrite it. If you want to divide, look on the right side, flip that fraction over, and then multiply. So I've got a bunch of cross reducing. Sometimes they call it cross reducing. We've been calling it simplifying before dividing. So the 9 and the 3 are both divisible by 3. So I divide 3 by 3 and get 1. 9 divided by 3 is 3. And the 8 and the 4 are both divisible by 2, but they're also divisible by 4, right? And I want to pick the larger number and divide it out. Then I get 3 times 2 over 1 times 1, which I know equals 6. Hey, that matches the picture that I did below. Again, you don't always have to draw a picture. And remember, this kind of a picture is helpful when you have a fractional divisor. Okay. So now I've got some OYOs. You're going to be writing these in your math notebook. You're going to be trying them on your own. I'm going to go ahead and put in the times and the plus, the times and the plus. Pause the video, try the math. I'll do mine. Remember, I always do all my converting before I do any flipping. And then I look to simplify before I multiply. I see a 2 and a 10. They're both divisible by 2. I end up with 5 times 3 over 7 times 1, which equals 15 sevenths. That is an improper fraction. I am going to change it back into a mixed number by dividing. That fraction bar means divide. 7 goes into 15 twice. I have 1 left over. I have 1 piece left over, and it was cut into sevenths. So I have 2 and 1 seventh. All right, for the second one, I end up with 13 sixths divided by 3 fourths. Then I rewrite it, and I get 13 sixths times 4 over 3. The 4 and the 6 are both divisible by 2. 13 times 2 is 26. 3 times 3 is 9. That is another improper fraction. So I'm going to divide 9 into 26. It goes 2 times. 9 times 2 is 18. When I subtract, I get 8 left over, and they are ninths. 2 and 8 ninths. So I'm going to put my answer over here and put a box around it. Okay, not that much different from what you were doing before. So now we have an example where I'm giving you 2 mixed numbers, right? So write down this example in your math notebook, and the idea is how many 1 and 2/3 fit inside of 3 and 5/6. Okay, so this gets a little complicated, but again, remember I said I want you to do the mixed numbers first. Don't flip it. 6 times 3 is 18 plus 5. So I get 23 sixths divided by 3 5/3. Okay, now I can go ahead and rewrite it. When you want to divide, look on the right side, put that fraction over, and then multiply. So 23 is a really big number. I wish it could simplify, but it turns out it's a prime number. So there's no common factors between 5 and 23. They're both prime, but the 3 and the 6, they both share 3. Divide out 3, divide out 3, I get 2. That leaves me with 23 times 1 over 2 times 5, which is 23 tenths. 23 tenths is a mixed number, improper fraction that needs to be turned into a mixed number. I have 3 left over. The sides are tenths. So I get 2 and 3 tenths. Okay, it kind of makes sense. If I was estimating, this would be about 4 divided by about 2, which is about 2. And 2 and 3 tenths is close to that. So if I go back to my skill of estimating to make sure that my answer is reasonable, that makes sense. Okay, now we're on the OYO. You're going to try these. Remember, please change your mixed number into improper before you do any math with them. Okay, 32 33 fourths divided by 3 halves. When you want to divide, look on the right side, flip that fraction over, and then multiply. And again, you might want to simplify before you multiply. Notice the 3 and 33 are divisible by 3. The 2 and 4 are divisible by 2. And I get 11 times 1 over 2 times 1 equals 11 tooths. And now I need to divide 2 into 11. Goes 5 times, I get 10, and 1 left over, 5.5. And the last one is 34 fifths divided by 17/8. When you want to divide, look on the right side, flip that fraction over, and then multiply. All right, so 34 is double 17, so I've divided both of these by 17. 17 divided by 17 is 1. 34 divided by 17 is 2. When I multiply across, I get 2 times 8 and 5 times 1, so I end up with 16 fifths. which is improper. I'm going to divide 5 into 16. It goes 3 times. I subtract, and I have 1 left over. So I got 3 1/5 as my answer. Okay, so that's how you divide when they're both mixed numbers. Just turn them into improper fractions. Now I want you to see a real life example where, yes, I sometimes set up problems or I want you to divide, but I want you to see that there's another way that you could probably do this. So here is Mrs. Clifner's way. If you are in a restaurant or you own a restaurant and you know that you have 50 cups of soup, and then you know that this is how much soup fits in one of the bowls that you have, right? When you measure it out, it's 1 2/3. So you want to give every patron who buys a bowl of soup the same amount because it wouldn't be fair. The question is, hey, are you going to be able to serve 35 people soup today? So you would be thinking about, I've got 50 cups. How many 1 2/3 cups fit inside? If I have at least 35, then I've got enough to serve those people. So I'm going to just change it to 50 over 1 divided by 3 times 1 is 3 plus 2, 5/3. And that becomes 50 over 1 times 3 over 5. 5 goes into 5 once, 5 goes into 50 10 times. Guess what? It looks like I only have enough to serve 30 bowls of soup. So I didn't have enough. But I was thinking, well, what if I did this? What if I knew that there was 35 people that I was serving and each person would get 1 2/3 cup of soup? So the word each, right, in this instance means multiply. So maybe I could have just figured out the problem by doing this math, which may look a little bit harder because the numbers are harder. So I have, remember when I multiply across, I have 35 times 5. So 25, 17, this equals 175 over 3. So now I need to divide to figure out exactly how many bowls of, this was the number of people, how many cups I have altogether, right? The people times the amount in each cup would give me the total that I have, hopefully, in my pot. 3 goes into 17 5 times. This is 15, 25, 3 times 8 is 24, and then I get 1/3. Oh, so this is how many cups. Oops, this is 30 people, so the answer is no. This would be how many cups I would need if I was going to serve 35 people. So obviously I could make what? I need to make a little more than 8 more cups of soup to make it happen. So I just want you to see that sometimes you can solve a problem using division or multiplication, depending on where your skills are. Okay, class 1, this is the OYO. I want you to think about what happens when you take your pet to a kennel or a friend's house. Maybe you have a friend who's going to watch your pet for a while, and you need to figure out if you're going to be giving them enough food. So again, maybe you could multiply, you know your dog eats 2 1/3 cups of food a day, but maybe you're looking at, well, what if I give my friend the whole bag of 42 cups? I wonder how many days that would feed my dog for. So you're trying to figure out 42 cups is the total. So how many 2 1/3 cup fit inside the 42 cups? So that's the division that you're going to be doing on your own. Go ahead and pause it. All right, so now I've got my multiplying that I'm doing. 7 goes into 7 once, 7 goes into 42 6 times. 6 times 3 over 1 times 1 equals 18. So the answer is 18 days. And remember, when I give you a word problem and there's a context, I want you to write the units with it. So that would be enough food for 18 days. And that's the end of the lesson. Bye-bye.